A 15 kg mass is accelerated from rest with a force of 100 Newton. As it moves faster, the friction force varies, A plus BV, where A and B are given. At what velocity is the acceleration equal to 1/2 of the initial acceleration? When I consider a mass, let us say m, and it is applied a force in the right hand side direction, the friction force will act in the opposite direction. So for any particular case, the total forward force F minus the total opposite force, that is the friction force, can be written as m into A. Now the total forward force is constant, which is equal to 100 Newton, minus the total force in the opposite direction will be equal to A plus BV, okay, will be equal to m into A. M over here is given as 15 into A. So basically 100 minus the value of A is given as 25, plus the value of B is given as 0.5 into V is equal to 15 into A. So basically it will be equal to 75 minus 0.5 V is equal to 15A. Now it is given that, now this is the general formula which can be applied anywhere, okay. Now when it was at rest, it means that initially when it started it was at rest, it means that the velocity was equal to 0. So basically 75 will be equal to 15A. So A will be equal to 5 meter per second square. So basically they have asked after how much velocity is attained, the acceleration will be equal to half of the initial value. So I will substitute the same thing over here, but instead of acceleration I will substitute 5 by 2, okay. So 15 into 5 by 2 is equal to 75 minus 0.5. They have asked after what velocity is attained, the acceleration will be equal to half of the initial value. So 75 minus 0.5 V will be equal to 15 into 5 by 2 will be equal to 37.5. So basically 0.5 V is equal to 37.5, or V will be equal to 37.5 divided by 0.5, which will be equal to 75 meter per second, which is option number C.